안녕하세요. 사회생활 46년 차 인공지능 아카데미 아재입니다. 오늘도 역시나 새벽 3시에 녹화를 하고 있는데요. 긴급 소식이기 때문에 여러분들한테 알려드립니다. 700억 개 모델이 4,050억 개 그리고 조 단위를 넘는 GPT4 옴니 등을 벤치마크 점수에서 성능을 뛰어넘는 기적같은 일이 일어났습니다. 지금 보시는 차트가 제가 데이터를 가지고 GPT4 옴니에서 만든 건데요. 지금 보시면은 Reflection 700억 개 모델이라고 합니다. 그리고 클로드 3.5 소넷, 클로드 3 오플스, GPT4 옴니, 제미나이 1.5 프로, 라마 3.1 4,050억 개 모델, 이 6개의 모델을 비교를 했는데요. Reflection 70B 모델은 라마 3.1을 리플렉션 튜닝을 한 겁니다. 쉽게 설명을 드리면은 셀프 힐링을 해서 자가 수정을 하고 스스로 고치는 학습 기법을 사용을 한 겁니다. 그저께 영상에서 제가 GPT5에 대해서 스트로베리와 오리온 프로젝트를 제가 말씀을 드렸죠. 거기에서 데이터의 부족 문제를 해결하기 위해서 스스로 데이터를 융합 생성해서 학습 데이터로 활용을 해서 자체적으로 학습을 데이터를 만들어 가지고 학습을 하는 새로운 기법을 훈련 기법을 GPT 측에서 진행을 하고 있다고 말씀을 드렸습니다. 그런데 여기서도 마찬가지로 비슷한 개념의 셀프 힐링 개념의 리플렉션 튜닝이라는 기법을 적용해서 라마 3.1 700억 개 모델을 가지고 4,050억 개 조 단위가 넘는 기존의 네노라고 하는 이 GPT와 클로드, 제미나이 1.5 프로 3대 천왕을 압살하는 성능을 보인 겁니다. 좀 서두가 길었죠. 흥분이 안 될 수가 없습니다. 더군다나 오픈 소스이고요. 로컬에서 설치해서 사용하기가 불편하신 분들은 또 서비스가 나와 있습니다. 그래서 오픈 AI가 처음 GPT를 내놓을 때 1인당 18달러 정도의 사용을 무료로 제공을 했어요. 저는 1몇 달러밖에 그 당시에는 워낙 LLM에 대해서 특히나 API를 가지고 이용하는 부분에 대해서 지식이 좀 부족해서 사용을 다 못하고 스테이블 디퓨전이나 미드저니 일반 챗봇을 공부하는 데 시간을 투자를 했었기 때문에 활용을 제대로 못했는데요. 굉장히 높은 성능을 가지고 있는 툴입니다. 아마도 지금부터는 셀프 치유, 셀프 훈련 이런 여러 가지 새로운 첨단 학습 기법이 나옴으로써 소형화된 모델들도 로컬에서 중소기업이나 작은 기업에서도 온디바이스 형태로 학습을 시키고 운용을 할 수 있는 시대가 곧 다올 것 같고 또 더 경량화되고 진보를 한다면은 개인들도 노트북 수준에서도 학습을 시키고 있는 시대가 다가오지 않겠느냐 그렇게 기대를 하면서 저 같은 저사양 컴퓨터를 가진 이용자도 내 목적에 맞게끔 쉽게 경량화된 모델을 통해서 온디바이스 형태로 학습을 시키고 나만의 GPT를 만들어서 챗봇을 만들어서 다양한 인공지능을 이용한 비즈니스 활동이나 콘텐츠 생성과 같은 일들을 할 수 있는 시대가 머지 않을 것 같습니다. 제 생각에는 1년 내 정도면 지금 이 리플렉션 70B 모델을 보면서 그런 걸 느끼네요. 그리고 기대감이 한층 더 올라갔고 실현되지 않을까 하는 생각을 하고 있습니다. 더 소개를 조금 해드리면은 매튜 버먼이라는 분이 토크를 하셨어요. 며칠 전에 제가 하는 걸 봤는데 크게 관심이 없어서 그분들이 나눈 대담의 기록이 15분 정도로 했는데 제가 한글 자막 처리를 인공지능 툴로 가지고 했습니다. 잠깐 보실까요? 이 매튜 슈머라는 분이고 다른 분은 제가 성함을 모르겠고요. 이 매튜 버먼이라는 분과 또 다른 한 분의 대담을 하는 겁니다.
Ah, there we go. Yes, we have sound. Massa Hill, can you hear me okay? All right. I think you might still be muted. I'm going to just do a quick intro.
I'm muted. Yeah, good now?
All right. Here we go. No sound. The sound should be coming in any moment now. No rip audio, no audio. Yep, it'll be fixed. I still don't know how to operate a mute button.
제일 위에 있는
All right,
좌측에 위에 있는
we got
분이
audio.
매트
Good.
슈머라는
Okay,
분이에요.
so today,
지금
super excited
주관을
to
하고
share.
있는 분이
We
매트
have two
버먼인데
special guests joining us today.
이분의 제가
Matt
내용도
Schumer,
많이
co-founder and CEO
구독을
of
하고 있는데
HyperWrite AI, and the author creator of the most recently dropped amazing open source open weights model Reflection70B. We also have Sahil Chowdhury from Glaive. He is the founder of Glaive, who was pivotal in helping get this model to everybody. So very excited to talk to you both. Thank you so much for joining me today. Cannot wait to hear more about what went into this model. But welcome to the stream, guys.
Thanks for having us.
All right. So first, let's just talk about what happened. So yesterday, actually, I'm going to share your Twitter post. Let's see. You probably posted a ton of stuff since yesterday.
Too much.
Cool. Here's the announcement. So Matt Schumer yesterday, 11:51 a.m. I'm excited to announce Reflection70B, the world's top open source model, trained using a new technique, reflection tuning. We'll talk about what that is today. And it is doing incredibly well. If you look at the benchmarks just across the board, competitive with the other frontier, both closed source and open source models, beating Llama 3.1.
이 내용은 앞에서 설명을 드렸기 때문에 넘어가고요. 지금 허깅 페이스에서 가장 인기 있는 모델 1위로 지금 올라갔다고 합니다. 여러분들이 개발자가 어떤 내용으로 개발을 했는지를 한번 들어보시겠습니다.
Myself and the company, right? So I've been personally starting companies since I was 12. We can skip a lot of time. A few years ago, when I was in college, I started Other Side AI, which is the company that sort of became HyperWrite, right? And the idea behind HyperWrite initially was, can we create an AI that can write your emails for you? We were actually the first that we're aware of VC-backed company in the sort of like quote-unquote generative AI space that used the OpenAI models at the beginning. We've grown quite a bit since then. Now we have, well, a few million users, millions in revenue. We're profitable. For a much sort of like expanded version of that product, it's sort of writing in general. We're the best AI for writing, continues to get better. We have a lot of sort of specific things we do, but that's the high level. In terms of this model, this is sort of just a fun thing. Very long story short, I was actually on vacation and my mind was just everywhere. And I was like, okay, I'm kind of bored of this. I need to actually do something productive. And I've been noodling on this idea for a very long time. And it was sort of like time to just do it. So towards the end of the trip, I actually reached out to Sahil and I was like, can we collaborate? And that's how this came to be.
How long ago was that?
3 weeks, I think.
So to be clear, you had the idea, reached out to Sahil, put together the data set, fine-tuned the model, and published it all within 3 weeks.
Yes. And I know that sounds crazy. I get that.
지금
But I think a
굉장히
lot of people
놀랍지
underestimate
않습니까?
what can be done
세계
today
최고
with a
성능의
very small amount of resources, right? Too many people look to the
모델을
big AI labs
만들어내는데
and are like,
불과
hey, look,
3주 만에
they spend billions of dollars
아이디어가
doing this.
떠올라서
There's no for anybody to compete with
했다고
a small
하는 게
budget and small team, small amount of time, right? But Sahil and I did this on the side, right? This wasn't even sort of our major focus, not even
우리나라도
close to
이런
it.
분이 계시면
And it's just thinking
좋겠네요.
about the problem in a different way, right? The data set was everything for this. And
작년
Glaive
3월 달에
made that possible
저분이
because we
개발한
kind of know what we were
부분이
going after. And
하이퍼라이트라는
once
게
we sort of
있어요.
had the idea
글쓰기
of what this would look like, it was very
인공지능
easy to
툴인데요.
actually put into
그 툴도
practice.
서비스도 굉장히 작년에
Awesome.
유명한
And on that note, Sahil,
고
please
인기가 좀
tell us about
있었던
yourself. Tell
건데
us about what Glaive does.
Yeah, kind of similar to Matt. I've been doing startups, specifically AI startups, for a few years now. Just before starting Glaive, I worked at a company called Banana, where we were building serverless GPUs for machine learning. Realized that people cannot host custom models because to have really high-performing custom models that are use case specific, you need high-quality data, and companies lack that most of the times. And that is when I decided to just be a founder and start Glaive. And Glaive is essentially a platform where companies can build use case specific data sets using our synthetic data generation pipeline and train models on that and basically keep iterating on them because it's, as I think Matt said, it's pretty
저도
quick to
기업을
iterate on data
경영을
sets
했던
with the help of
사람으로서
synthetic data.
경영
The generation
인공지능
process is pretty quick.
아카데미라는 1인
Yeah.
법인을 운영을 하고 있지만은
That's
이런 분들을 보면
that's
우리나라의 젊은
Cool. So,
청년들께서도
I mean, Matt, you said
아이디어가
it, the data set is
있으면은
everything, but
공격적으로
I want
도전을
to touch on that a
해서
little bit because
이런
we can talk about
세계적인
publicly
성과를
available data
거두시는
in
분들이 사람들이
how
많이
that is
나오기를 진심으로
essentially
바랍니다.
all used in current frontier
그리고
models.
그렇게 할 수 있다고 저는
And there's really like
믿거든요.
two solutions to that. You either create synthetic data or you do more with the data that you have. And so
여기서도 보면은 합성 데이터를
with
생성하는 부분이
reflection and
나오죠.
what makes reflection special? What is
GPT4라고 하는
the
가칭
secret sauce there?
스트로베리와 오리온 프로젝트에서도
Yeah, so I think
스스로 데이터 부족 문제를 해결하기 위해서 합성 데이터를 생성해서 자가 훈련하는 셀프, 그래서 GPT5가 기대가 된다고 했는데 여기에서 오히려 더 선수를 친 것 같아요. 이 매트 슈머라는 젊은 청년 사업가가 아이디어를 구상을 해서 3주 만에 이런 모델을 내놓고 이런 걸 보면은 우리나라의 청년들도 충분히 할 수 있지 않느냐 그런 생각을 합니다.
So we do a lot of work with that. And one of the things that I've realized is like, as a person, I can think through a problem, but I'm not always going to get every little bit right. And what happens if I get something wrong? Well, personally, I reflect and I'm like, wait, I made a mistake.
이 약 35분 정도 되는데요. 이 영상은 제가 별도로 올려드리든지 아니면은 제가 생각 중인데 이 영상 오늘 새벽 3시여서 제가 이 영상을 후반부에다가 붙여서 삽입을 하든지 한번 생각을 해보고 결정을 해서 올리겠습니다.
And if we could essentially teach the model to think more like we do and actually reflect on behavior that it makes a mistake in, the model gets
지금 리플렉션 튜닝이라는 부분에 대해서 설명을 하고 있네요. 스스로 힐링하고 셀프 힐링이라고 이 매트 버먼 씨는 표현을 했는데요.
what we call like our own splitting strategy that allows the model to not learn to make mistakes, because if you do this wrong, it's very easy to teach the model to make more mistakes and then fix them. The idea is to keep
보통 지금까지의 프롬프트 기법은 실수를 가르치기보다는 예시를 들어서 정답을 가르치는 방법이었는데요. 여기에서는 실수를 많이 하고 실수를 수정해 나가는 방법을 학습을 시켜서 이렇게 놀라운 성과를 거두었습니다. 제가 다음 영상으로 예고인데요. 보시면은 놀랍게도 이런 성과를 거두기 위한 데이터 세트가 크지 않았다고 이야기를 하거든요. 10,000개의 샘플로 시작했다고 하니까 이제 10만 개까지 확장을 했다고 하는데 10만 개 정도의 데이터를 가지고 할 수 있다면 우리나라 기업들이나 청년 연구소 같은 데도 충분히 할 수 있지 않겠느냐.
The goal really wasn't to get a lot of data and teach the model how to reason, but it was essentially to teach the model to recognize its own mistake. And I think to that point, I see a lot of people mention that you can kind of get similar gains out of just prompting regular instruct models to use reflection. And I think that's true to some extent. You can get a percentage of the gains by just prompting. But if you try to prompt even Sonnet 3.5, for example,
너무 기니까 전문적인 내용이니까 이 정도까지 제가 소개를 하고요. 이 영상에 대해서 관심이 있으신 분들은 제가 한글 자막화했던 부분은 내용을 추가를 해서 별도로 올리든지 하겠습니다. 그리고 오늘 제가 이 영상의 후속편으로 나갈 부분을 예고 성격으로 좀 드리는데요. 엔스로픽에서 메타 프롬프트를 만들어서 몇 시간 전에 공개를 했습니다. 클로드 프롬프트 제너레이터라고 해서 보시면 알겠지만 기덥에 발표를 했는데요. 이 프롬프트는 뭐냐, 메타 프롬프트는 프롬프트를 개선시켜주는 프롬프트입니다. 일반인들이 사용할 수 있는 방법, 챗봇에서도 사용할 수 있는 방법, 그리고 이 프롬프트를 한글화를 시켜서 여러분들이 일반 챗봇에 영어 파일과 한글 파일을 메타 프롬프트 두 개의 파일을 첨부를 하고 여러분들이 내가 다음 영상으로 알려드리는 방법으로 사용을 하시면은 현재보다 굉장히 향상된 성능, 그리고 프롬프트 때문에 고생을 덜 하시고 전문가가 아니더라도 전문가처럼 프롬프트를 활용할 수 있는 영상을 이 후속으로 바로 나갈 것 같습니다. 그 점 참고해 주시고요. 또 이 내용을 계속해서 설명을 드릴 게 몇 가지가 있습니다. 매트 버먼 씨와 매트 슈머 씨가 대담을 통해서 밝혔는데요. 또 더 추가로 더 이야기할 부분이 뭐가 있느냐면 소개할 부분이 이 하이브볼릭 랩스에서 첫 이 리플렉션 라마 3.1 700억 개 모델을 런칭을 했다고 해요. 그래서 여기에 유첸진이라는 중국계 분이신데 이분이 하이퍼볼릭과 곧 공개를 합니다 했는데 실제로 공개가 됐습니다. 그건 조금 이따가 소개를 해드릴게요. 호프백 4대 정도를 가지고 운영을 하는데 앞으로 수요가 많이 늘어날 것 같아서 정설을 확장이 가능하도록 했다고 합니다. 그래서 Thinking Reflection 출력의 태그가 있습니다. 오픈소스와 클로즈드 소스에서 최고의 LLM인지 확인할 시간입니다. 그러니까 이제 Reflection 700억 개 모델을 가지고 와서 폐쇄형인 이 하이퍼볼릭이라는 곳에 보시면은 700억 개 모델이 새로 등장을 했습니다. 그리고 라마 3.1의 4050억 개 기본 모델도 등장을 했고요. 이 부분을 활용을 해서 여러분들이 사용하실 수가 있는데 처음 가입을 하시면은 $10를 줍니다. 하이퍼볼릭이라는 데서도 이 리플렉션 700억 개 모델 뿐만 아니라 4050억 개 모델 다양하게 있는데 굳이 이 부분을 쓸 필요가 없죠. 보여드렸던 대로 성능이 리플렉션 700억 개 모델이 지금 초대형 어느 모델보다도 더 뛰어난 성능을 보이고 있기 때문에 여러분들이 일주일간 무료를 제공한다고 합니다. 하이퍼볼릭이 일주일간 무료로 제공하기 때문에 여러분들이 체험을 해보세요. 여러분들이 700억 대 모델을 이용을 해볼 수가 있고 오픈소스이기 때문에 로컬에 설치하는 부분도 활용을 하실 수가 있는데 그 부분은 긴급으로 속보 형식으로 간단하게 소개를 해드리고 오픈소스로 설치하는 부분은 제가 조사해서 링크를 고정 댓글에다가 걸어드릴 테니까 사용을 해보시면 좋을 것 같습니다. 오늘은 2개의 시리즈로 영상이 나갈 건데요. 세계 최고의 성능을 보이는 리플렉션 700억 개 모델을 소개를 시켜드리고 후속 영상으로는 모든 챗봇에서 여러분들이 쓸 수 있는 엔스로픽에서 공개한 이 클로드 프롬프트 제너레이터라고 하는 한글판과 영문판을 제공을 해드릴 테니까 구글폼으로 신청을 하셔도 되고 영문판은 기덥에 링크를 걸어 드릴 테니까 사용을 해보시면 되는데 제가 다음 영상으로 통해서 어떻게 활용하면은 일반인들도 챗봇에서 클로드 프롬프트 제너레이터를 가지고 효과적으로 프롬프트를 생성을 해서 정확한 답을 얻을 수 있는지 그리고 그 편에는 놀라운 프롬프트가 하나가 추가가 됩니다. 그저께도 제가 영상을 올렸지만은 오늘 올려드리는 프롬프트 하나가 결과로 클로드 3.5가 반응하는 올려놓는 결과물이 완전히 바뀌게 되는 것을 그 영상을 통해서 확인하실 수 있으니까 기대하시고 다음 영상 많이 관심과 응원 부탁드리겠습니다. 또 좋은 소식, 유익한 정보, 즐거운 콘텐츠로 찾아뵙겠습니다. 감사합니다. 고맙습니다.
Ah, there we go. Yes, we have sound. Massa Hill, can you hear me okay? All right, I think you might still be muted. I'm going to just do a quick intro.
I'm muted. Yeah, good now?
All right, here we go. No sound. The sound should be coming in any moment now. No rip audio, no audio. Yep, it'll be fixed. I still don't know how to operate a mute button. All right, we got audio. Good. Okay, so today, super excited to share. We have 2 special guests joining us today. Matt Schumer, co-founder and CEO of HyperWrite AI, and the author-creator of the most recently dropped amazing open source open weights model Reflection70B. We also have Sahil Chowdhury from Glaive. He is the founder of Glaive, who was pivotal in helping get this model to everybody. So very excited to talk to you both. Thank you so much for joining me today. Cannot wait to hear more about what went into this model, but welcome to the stream, guys.
Thanks for having us.
All right. So first, let's just talk about what happened. So yesterday, actually, I'm going to share your Twitter post. Let's see. You probably posted a ton of stuff since yesterday.
Too much.
Cool. Here's the announcement. So Matt Schumer yesterday, 11:51 a.m. I'm excited to announce Reflection70B, the world's top open source model, trained using a new technique, reflection tuning. We'll talk about what that is today. And it is doing incredibly well. if you look at the benchmarks, just across the board, competitive with the other frontier, both closed source and open source models, beating Llama 3.1405B, the larger one. And according to Matt, we have the 405B model coming out next week. So first, Matt, maybe just tell us a little bit about yourself. What do you do, and what made you want to create this model?
Yeah, so high level on myself and the company, right? So I've been personally starting companies since I was 12. We can skip a lot of time. A few years ago, when I was in college, I started Otherside AI, which is the company that sort of became HyperWrite, right? And the idea behind HyperWrite initially was, can we create an AI that can write your emails for you? We were actually the first that we're aware of VC-backed company in the sort of like quote unquote generative AI space that used the OpenAI models at the beginning. We've grown quite a bit since then. Now we have, a few million users, millions in revenue. We're profitable. For a much sort of like expanded version of that product, it's sort of writing in general. We're the best AI for writing, continues to get better. We have a lot of sort of specific things we do, but that's the high level. In terms of this model, this is sort of just a fun thing. Very long story short, I was actually on vacation and my mind was just everywhere, and I was like, okay, I'm kind of bored of this. I need to actually do something productive, and I've been noodling on this idea for a very long time, and it was sort of like time to just do it. So towards the end of the trip, I actually reached out to Sahil, and I was like, can we collaborate? And that's how this came to be.
How long ago was that?
3 weeks, I think.
So to be clear, you had the idea, reached out to Sahil, put together the data set, fine-tuned the model, and published it all within 3 weeks.
Yes. And I know that sounds crazy. I get that. But I think a lot of people underestimate what can be done today with a very small amount of resources, right? Too many people look to the big AI labs and they're like, hey, look, they spend billions of dollars doing this. There's no hope for anybody to compete with a small budget and small team, small amount of time, right? But Sahil and I did this on the side, right? This wasn't even sort of our major focus, not even close to it. And it's just thinking about the problem in a different way, right? The data set was everything for this, and Glaive made that possible. We just had to kind of know what we were going after. And once we sort of had the idea of what this would look like, it was very easy to actually put into practice.
Awesome. And on that note, Sahil, please tell us about yourself. Tell us about what Glaive does.
Yeah. Kind of similar to Matt. I've been doing startups, specifically AI startups, for a few years now. Just before starting Glaive, I worked at a company called Banana, where we were building serverless GPUs for machine learning. Realized that people cannot host custom models, because to have really high-performing custom models that are use case specific, you need high-quality data, and companies lack that most of the times. And that is when I decided to just be a founder and start Glaive. And Glaive is essentially a platform where companies can build use case specific data sets using our synthetic data generation pipeline and train models on that, and basically keep iterating on them. Because it's, as I think Matt said, it's pretty quick to iterate on data sets with the help of synthetic data. The generation process is pretty quick. Yeah, that's summary.
Cool. So, I mean, Matt, you said it, the data set is everything, but I want to touch on that a little bit, because we can talk about, publicly available data and how that is essentially all used in current frontier models. And there's really like two solutions to that. You either create synthetic data or you do more with the data that you have. And so which approach did you take with Reflection, and what makes Reflection special? What is the secret sauce there?
Yeah, so I think Sahil could probably talk more to the specifics of the data side and how the data set was constructed. I can talk more to the sort of idea behind Reflection and why it works. So at a high level, right, the general idea is LLMs are sort of getting to the point where they can think, quote unquote think, and it's sort of mirrored after how a human thinks, right? You kind of talk through it in your head. Some people do it differently, but some people kind of talk through the problem in their head and arrive at an answer. And LLMs do that today with chain of thought. That's how they have, it's one of the reasons they've improved in performance so much over the last few years. It's been a cornerstone of pretty much every major LLM. whether it's coding, whether it's just general reasoning or writing even. So we do a lot of work with that. And one of the things that I realized is like, look, as a person, I can think through a problem, but I'm not always going to get every little bit right. And what happens if I get something wrong? Well, personally, I reflect and I'm like, wait, I made a mistake. I backtrack and I fix myself. But an LLM doesn't do that. One of the things we noticed is that LLMs, once they make that first mistake, they kind of accept it as fact, right? If I'm asking it 2 plus 2 and then multiply that by 7, right? And it says, okay, I'll do that. Let's start with 2 plus 2. That equals 5. And then 5 times 7, right? It's already made that mistake and it's just assuming the thing that it said is right. And if we could essentially teach the model to think more like we do and actually reflect on behavior that it makes a mistake in, the model gets smarter. It gets more reliable. It gets more accurate. So that's generally the idea here. And we did a lot of, even beyond the data, it's how we trained the model, right? We created what we call like our own splitting strategy that allows the model to not learn to make mistakes, because if you do this wrong, it's very easy to teach the model to make more mistakes and then fix them. The idea is to keep the model's performance as is or make it even better. And then on the things where it actually ends up making a mistake, and it would no matter what, we can fix that. And it's still not perfect. It's still very early. It's still the first version of this, but I think we've come quite a bit away in a few weeks. So that's sort of like how it works. Sahil, maybe you want to talk a little bit more to the data generation process itself, because that was all you.
Yeah, I can do that. Surprisingly, the data set we used for this isn't that big to what people would expect. It's roughly, we generated it in steps. We started out with, I think, just 10,000 samples to see if this is actually possible, and we scaled up to 100,000 samples. We decided that we'll do some code data, some math data, general reasoning, function calling, and multi-turn. So the goal really wasn't to get a lot of data and teach the model how to reason, but it was essentially to teach the model to recognize its own mistake. And I think to that point, see a lot of people mention that you can kind of get similar gains out of just prompting regular instruct models to use reflection. And I think that's true to some extent. You can get a percentage of the gains by just prompting. But if you try to prompt even Sonnet 3.5, for example, you'll see that there's a lot of bias in the model outputs where the model almost always believes that what it's saying is correct. And we face that problem in data generation as well, right? Like we use language models, we use fine-tuned language models to generate synthetic data. And when we first tried to actually generate reflection data, we realized that if we ask the model to actually make a mistake and then reflect on it, models are really bad at doing that. Maybe it's just RLHC. If you do that, like the models will make mistakes easily, but if you ask a model to deliberately make a mistake, it just won't be able to. And that was the main goal of just fine tuning, right? To teach the model that it can actually make mistakes and correct that.
Yeah, I have so many questions about this. So for those of you watching, maybe this is a good way to break it down. You effectively took really kind of sophisticated prompt engineering strategies, even something as simple as explain your reasoning step by step, which is something that I put into all of my prompts when I'm giving it more complex reasoning and logic questions. But you can get obviously even more sophisticated than that, chain of thought, and so on. And so you've taken that and you've built it into the model itself, and you've actually given it examples of making mistakes along the way. And that's actually what I'm showing, I believe, on the screen right here. Actually, there's a lot going on. Hopefully y'all can see it. But effectively, you're teaching the model in the fine-tuning data itself to think through everything, more step by step, but also to, and hence the name, reflect on the output as it's doing the inference, and then potentially correct itself during the inference process. So first of all, what was the trigger for thinking that this would be really a good strategy? And then why is it better than simply having a system message with some of this prompting techniques or putting it in the prompt itself?
Yeah, I mean, why don't I start with what you just asked the last question. Sahil covered a little bit of this. Some of my personal findings with this, because I've been prompt engineering for too many years now, like basically since 2019 with GPT-2. What I found was essentially if you asked it to do this and didn't train on it, a couple things would happen. Sometimes it was sort of like what Sahil was talking about, where the model was overconfident. But there was another issue I found, which is sometimes, this is kind of getting a little weird, the model would actually deliberately make mistakes that it wouldn't have made otherwise. Because when you're prompting, it really wants to follow those instructions. It really wants to follow that system prompt. And if you say, when you make a mistake, fix it with a reflection tag, you're going to notice that it's going to make that mistake. What you notice with our model is that it doesn't always use reflection. It only uses it when it really thinks it needs to. Sometimes a little bit too much, but we're much more towards the end of like, use it when you need to, don't when you don't. Because if you're teaching it to do it all the time, right, it's just going to make mistakes deliberately. So yeah, it doesn't really work for prompting. And I do have to apologize. Like I said, I've not slept in 2 days. So what was the first part of your question?
No, I'm trying to understand like what the reasoning is, like what if it's better to put the prompt in the actual fine-tuned data, or if it's better to do it afterwards. And obviously, like your model is crushing the benchmark, so you've done something really well. But like, what was that idea that made you think that it's actually like let's push this to the fine-tune itself?
Yeah, I mean, I've had this idea, like I mentioned, for many months now in different forms of it. So it was sort of like, how do you enable that for everyone without them needing to figure it out themselves? But even if they wanted to figure it out themselves, without a fine tune, it doesn't work super well. Prompting, like Sahil said, can get you a marginal gain. Like you definitely will see better performance, but it's not going to be the performance jump we saw. I mean, we saw 10+% jumps in many benchmarks. I mean, it was taking almost 70B and bringing it past 4 or 5B and much further beyond that. I mean, what we're expecting to see with 4 or 5B is going to be hopefully insane. So yeah, it's really that this can't be done with prompting alone if you really want to get the full force of it. This is closer to how people think. I think there are many more gains we can make there. And it was just one of those stupid, obvious ideas that no one really thought to do. Right? I think a lot of the major labs, they're way too in the weeds in many ways. They're thinking too technically and too intelligently about this, where sometimes the simple thing is what actually is going to work. Right? Just like so many people back in, 2018, whatever, they were working on all these new architectures, but scaling the one we had was the right answer.
Yeah, and Sahil, I think you mentioned like putting almost like telling the model to make the mistake and then showing it how to correct itself is one of the secrets to reflection. But you also said if you do that too much, it will just start making mistakes. What is that balance? How did you discover where that kind of cliff is before it started just taking those mistakes and accepting them as truth?
Yeah, I think there's a bunch of small details there. And I think next week when we put out like a technical report, it's going to help people understand that as well. But essentially, if you look at the responses the model generates, you'll see and somewhere under it's not always structured, but it's going to classify whether the problem is a hard problem, a moderate, or an easy problem. And you're going to see that it only uses reflection engine of thought for problems it thinks is a hard problem for itself. And that was part of the training. So we only added reflections. We classified problems as easy, moderate, and hard, and we only added reflections to the hard problems because you don't always need reflections. You don't want to teach the model to overthink. That was one part of it. And I think the second balance is we also added data samples, which are essentially just reflections, but the model reflects on something it did which was correct and just realizes that it does not need to actually course correct and it was already correct, and move on with the existing chain of thought. So we try to balance it out with these type of samples, trying to cover as many edge cases as possible. I think there's still room for improvement. But it was essentially, I think someone on Twitter found out that this was V5 of the model we trained. We had like V1, 2, 3, and 4. And that's essentially what it was, training model and figuring out how to balance the data set even more.
So if we're looking at this example, I guess I'm trying to figure out, you give it a prompt and it's running inference and outputting. Is it truly able to reflect on the output as it's giving the output? Like what does that flow look like?
Yeah, so that was actually a very intentional design decision where I think a lot of people get frustrated when they look at, and this is actually something we learned from Hyperwrite. People get frustrated when they see chain of thought. Some of the more power usery people, they like it, but your average user doesn't. They just want to know the answer to the question. And if they want to dive deeper, great, but they don't always want to dive deeper, and they don't want to dig through amount of text, chain of thought text, to find that answer. So this gets even worse with reflection, right? Because when it's reflecting in its output, it's like, oh my God, there's so much going on here. How do I parse through this? It's just, the cognitive load is crazy. So how can we fix that? And one of the ideas we had was just separate the reasoning out, right? Especially as inference is getting faster. Look at what's going on with, for example, Grok and Cerebrus, right? Inference is going to get way, way faster. And if we can do some of the thinking up front and just sort of hide that from the user and show it optionally if they want to see it, and then spit out a perfect answer at the end, that's what is ideal for most users in most use cases. So the idea here is, right, the model will start reasoning inside sort of what we call output tags, or sorry, thinking tags. So it'll
and
sort of
that's what we're seeing right here.
Yeah. It's going to start thinking, it does its reflections in there, it does its chain of thought in there, it does all its planning, all of that. And then it's like, okay, once it's got the right answer, or it thinks it's got the right answer, it's like, I'm done. Then it says, okay, time for an output. Here's what I'm going to show the user. And it writes the final message to the user. And I think different companies and different use cases and interfaces will use this differently. Some people will want to see it all. Some people want to make it optional. Some people want to hide it entirely. But I think that especially as models get faster and the actual sort of thinking process takes like less than a second, for example, I think this is the right approach.
And so that was the purpose of the tags, just to clarify. So you have the thinking tags. If you don't want to see the thinking, you just want the output, it's kind of like standard mode, and then you have advanced mode. And then you can actually see what's going on. Personally, I love seeing it. Like, I want to know what it's thinking, why it's thinking that, and that can actually help you kind of recraft the original prompt if you need to, because you could see if there's a misunderstanding or not. So, like, what are your thoughts on this method of self-correction during inference time versus, let's say, having multiple large language models working in collaboration, correcting each other? How does this differ?
Why not use them both? Right? Everything can build on everything.
Hell yeah.
And if you can have multiple of these models, right, thinking about different angles on each problem, and you have reflection within each model, it's just like having a better model going after a problem, but having them do it together.
Okay, amazing. And then one last question for me, and then I know we have a bunch of questions in the chat, so hopefully, I know you have probably about 12 more minutes, so hopefully we'll get to them both. What have you seen in terms of token usage on output as compared to a non-reflection model?
Definitely more. Sahil, you might have a much better response than definitely more.
Yeah, I haven't tested out, like, I don't have exact numbers to share right now, but from just the tests I've run, it seems to be 1.5 to 2 times the number of tokens for harder problems. So it's definitely generating a lot more tokens. And yeah, I think if you're using a hosted API, that causes the cost of the latency problem. But again, I think, as Matt said, inference is going to get much faster and cheaper. So we're kind of betting on that as well.
All right. Thank you. So we got a bunch of questions already. We're using a new streaming software. I'm not sure how to put it on the screen, so I'm just going to read them. Tresor asks, will it be possible to fine-tune other models like GPT4o mini to implement the reflection approach? So basically, does this data set, does this approach work across the board?
It should. There will be constraints with closed provider fine-tunings because they often have their own limits on how you can actually do the fine-tuning. So we'll go into this in more detail when we release a report, and we I think are going to be releasing the data set. We're still making the final decision there, but it's likely going to be a yes. It has to be trained in a very specific way. It's a very simple training process. It's straight up just like standard fine-tuning, right? There's no RLHF going on, none of that. But the way the data is sort of split up, it's to sort of like enable it to not learn to make extra mistakes, but learn to correct them. So for any open source model, it should be doable and relatively easy compared to some of the other approaches people have put forward. For things like fine-tuning OpenAI, maybe it's possible, especially if you're creative about it. I haven't fine-tuned on the OpenAI API in a while, but from what I remember, it would be a little bit limiting for something like this.
Yeah, and I like what you said earlier. This was just an overlooked strategy. Like it's maybe it was too simple. That's not to be pejorative at all. It's like,
but it is.
You know, sometimes it's just like, hey, it's right in front of you. Here's a great strategy you can use. So Yash asks, what about an 8B version? And we know you mentioned the 405B is coming out. What about an 8B version that more people can run maybe locally?
Yeah, I mean, we found, and to be fair, we trained the 8B first, but we found that it made some big improvements in certain benchmarks, but others it really didn't. And 8B, we weren't really sure where some of the gains were coming from. It felt like it was a little too dumb to pick up on this perfectly. Like the 70B definitely sort of like crossed a threshold where it was like able to grok this to some extent. But given the sort of crazy interest we've seen, like we expected this to do well. We didn't expect it to do this well. Like it's been the craziest launch of my life. Given that, I think there probably is enough interest to figure out something there. But you know, you said before, right? There are many things that are sort of like these low-hanging fruit things that people just don't pay attention to. And we have a few other ideas in mind that I think could do far better than reflection. So I think it's a question of, do we want to focus more on reflection and really optimizing an 8B that, you know, may be obsolete soon, or really going crazy and focusing on something that could actually top this by a good bit? And I think I'm more excited about the latter. But
I was just about to ask you that, Matt. Sorry to cut you off. I was just about to ask if you have any kind of new ideas going on. Do you want to hint at anything or not quite yet?
I think if you look at my past work and you think about this from the perspective of like, look, some of the learnings we've gotten from prompting have not been properly thought about in terms of training them into the model. I think you can kind of see where I'm going with this. There are a few different ideas that I'm kind of toying with and we're talking about right now. And I think the interesting thing is with Glaive, like they're not going to be so hard to implement. They actually might be even easier than reflection. They can be combined with reflection. But yeah, I think it's the idea of like, we're going to start exploring what it looks like to take these things that make it better from a prompting perspective. And can you make it much better by training on that? How do you give everyone the power of like the world-class prompt engineering sort of stuff baked into the model and even go beyond that? That's kind of how I'm thinking about it.
That's great. And, you know, Victor asked kind of as an extension of that, are you going to provide the data sets publicly so other people can maybe, you know, manicure them as they see fit and roll their own?
I think it's highly likely, Sahil, if you have different feelings, that we can figure that out.
No, I think in the past, like most of the open source work we have done has always included data sets. We're essentially a data set company, so it makes sense. Plus, it just makes it really easy for people to reproduce the benchmarks, the technique. So overall, I think it would make sense to open source once we have the 405B trained as well.
Awesome. Mark Cox asks, how exactly does it recognize a quote unquote mistake that requires a reflection? And actually, I have even kind of a follow up to that. Does it always output a reflection? Is it always necessary?
No. So in the dataset, we only have reflections as part of samples where the model is likely to make mistakes. And we decided that by just classifying the problem as hard. So if you just ask simple question, it won't add a reflection tag. If the question is really simple, it won't even do chain of thought and just answer pretty straightforwardly. So model can almost infer the difficulty of a problem and decide when to do reflections. But we've tried to train the model to do reflections whenever it makes, it solves a hard problem and it encounters a step where it's making a hard chain of thought step. So even if you have a really complicated problem, there will be like a few steps within that problem that the model is more likely to make mistakes. And we have added reflections in the data set right at that step. So whenever it makes, for example, it does arithmetic, it's more likely to just use a reflection tag right after that and see if what it did was correct or not.
Okay, great. Alex Volkov asks, any gut feeling about using MOE, mixture of experts, and this technique? Maybe if some experts are trained like this and others aren't.
First of all, hi, Alex. I don't know. I don't see why it would be much different. I've had poorer experiences training on mixture of experts models just generally. So I don't know if you found the same.
Yeah. I mean, one benefit could be that if there's an inference speed trade-off, because MOEs are usually faster to inference, that could be a benefit. Intuitively, I don't think we would see any performance gain relative to just these dense models. But again, I never tried this, so I'm sure.
Okay.
But people will be able to try it next week, especially if we have the data out. So hopefully
Awesome.
everyone does.
Yeah, I mean, once you do that, I'm sure everybody wants to get their hands on it, try experiment with their own techniques built on top of what you've done with reflection. So, and then actually another one from Alex, effects on quantization of this. And Matt, we were talking about this earlier. I'm planning on running it through my full LLM test suite, and I want to download it. I have 2 RTX A6000s. Maybe that was enough for, I think you said FP8. But how do you see quantization affecting the quality of the output using this technique?
I don't know for sure. I do suspect, especially from my limited testing of, like, there's already an API that's up that is FP8. I do suspect there's definitely a performance loss. I just don't know how much it is, right? Maybe it's 1% and it really doesn't matter. Maybe it is more than that. I do think from what I saw at a minimum, it is much less consistent. I did notice that. I just haven't spent enough time with it personally.
Okay. Daniel Ranger is asking about context length. Is there a reason why the context length is 4K instead of 128K? And I guess, how have you seen, maybe that's not the case based on your reaction, how have you seen context length affect the performance of the model? And maybe you could just clarify what the context length is.
It should be the full Llama, I believe, one. Go ahead.
Yeah, so it's the full Llama context length, I think 128K, around that. I just caveat that we haven't included data that's very long context in the training. So we don't know how the performance will be on very long context, and that's something to improve on in the future. But you can essentially run it through the entire context length of Llama 3.1.
Awesome. Yeah. Okay, I know you guys got to go in like 2 minutes, so I'll just wrap it up quickly. Your post got 2.2 million views. Matt, we have 1,700 plus viewers in here and growing. It keeps going up. So I think there's a lot of appreciation for what you've done, and you as well, Sahil. I just want to say thank you, especially like from the open source community. I love seeing open source compete with closed source frontier models. It makes me so happy that I can download this stuff and play with it myself. So thank you so much. If you want to check out Matt, here's his Twitter right here, Matt Schumer _ and he is the CEO and founder of Hyperwrite. So check out Hyperwrite AI. And all of this was built with Sahil's company. Founder of Glaive, Glaive. So glaive.ai, I believe it is. Is that right, Sahil?
Yeah, that's correct.
Yeah, so if you have a novel approach, just like Matt did, contact Sahil at Glaive and you can make it happen. And I just want to say thank you both. I mean, this was like a last minute thing. You just pinged me, Matt, and I was so happy you agreed to join. You too, Sahil. So thank you so much. Thanks to everybody who joined. And I'm glad we got some details.
Yeah, thank you for having us, and thank you for the support.
Yeah.
All right. You know where to find them. We'll drop it all in the description.